Good evening, students. In last class, we discussed about what is light and types of light and characteristics of wave of light and principle of superposition and coherent source and different kinds of characteristics of wave optics. Then before going to interference, we need to understand what is coherent source and what is superimposition. So based on coherence and superimposition principle, the interference phenomena will be understood. So what is interference of light? A phenomena in which two or more light waves. What light waves? It is coherent light waves having same amplitude and same frequency overlap each other to form a resultant light waves. What is resultant wave here? That is superimposition of the light. The intensity is greater or lesser than the individual waves is called interference of light. Interference of light. Then here it is, we have two types of interferences. So what is in the two types of interference? One is constructive interference and second one is destructive interference. So what is constructive interference? When the intensity of resultant waves, when the intensity of resultant wave is greater than the individual interfering waves, then the phenomena is called constructive interference. Then coming to destructive interference. So here it is, the intensity of resultant wave is less than, that is the less than of the individual interfering waves. This phenomena is known as destructive interference. Okay. So we already see the previous class, that is wave characteristics of wave. So what is crest, what is amplitude, what is wavelength. So these things are we already discussed in last class. So coming to constructive and destructive interference. If you observe here, here it is the constructive interference. That means the same waves are which is travel with same crust and same trough. Crust and trough which is travels with same amplitude. The resultant amplitude will be the highest resultant amplitude. If you see here, the resultant amplitude with the highest intensity. So this will be these phenomena, the complete phenomena is known as constructive interference. So what is destructive? Here the two waves are traveling but with different amplitudes and different wavelengths. That is the opposite trough and crust. So the resultant amplitude will be less than individual interfering. So here it is greater than individual interfering. Here it is less than interfering. So that is known as destructive interference. Okay, we have what is interference? The interference with the two waves, the phenomena of interference, the two or more coherent waves which is travel same amplitude and frequency with superimposition of waves, that phenomena is known as interference. So in interference there is two types of interference, constructive and destructive interference. Then next one, types of interference. We already seen what is phase difference and what is path difference. So the types of interference, first one is constructive interference. Constructive interference, that is occurs when the crest of one wave meets the crest of another wave. So we already seen in the diagram the crest of one wave and the crest of another waves which is travels with same. So that is named as constructive interference, right? So the constructive interference, the constructive interference So constructive interference. It is occurs crest of one wave meets the crest of another wave. That is a trough meets trough, or crust meets crust. So that is constructive interference. So what will be the result? So what will be the result? The result will be the amplitudes adds up and leading maximum intensity. So that is bright fringes. So based on interference, we have an important experiment in our class or in our subject, that is Newton rings. So after interference, we will discuss about Newton rings experiment 2. So what will be the resultant? The amplitude add up, the amplitude will be add and leading the to maximum intensity. For maximum intensity, that is bright fringe of light, the phase difference. So we can discussed already, the phase difference will represent in radians. Okay, that is 0, 2 pi, 4 pi, that is even multiple of pi. So what will be the path difference? Path difference, that is we can represent it as an lambda, that is delta x equal to 0, lambda, 2 lambda, 3 lambda, that is integer multiple of lambda. So here is the lambda will be the wavelength, right? So coming to destructive interference. In destructive interference, which means the crust meets trough. What is in constructive interference? The crust meets crust, the trough meets trough. So what will be the result? That is maximum intensity. And destructive interference, the crust meets trough, the trough meets crust. So each one is opposite direction. So that will be the, what will be the result? The minimum intensity that will form the dark fringes and the amplitude will be cancelled out. That amplitude will cancel out is nothing but a 0. So that amplitude cancel out, that is dark fringes resultant. So what will be the phase difference? Phase difference, that is pi, 3 pi, 5 pi, that is odd number of multiple of pi. Here it is even multiple of pi in constructive. In destructive, it is odd multiple of pi. Path is path difference. What is path difference? That is lambda by 2, 3 lambda by 2, 5 lambda by 2, that is odd multiple of lambda by 2. But in constructive it is 0, pi, 2 pi. In path difference in destructive interference, that is lambda by 2, 3 lambda by 2, 5 lambda by 2, that is odd multiple of lambda by 2. Next one. See, we can observe here. So with diagrammatically constructive and destructive interferences. Though here it is the constructive interference. See the waves, the crust meets crust, the trough meets trough, the crust meets crust and trough meets trough. So these two waves are travels with same amplitude and the resultant will be the resultant vector, like resultant wave will be with highest intensity. So with highest intensity. But in destructive interference, here the trough meets crust and trough meets crust meets trough. So the amplitude will be 0. So the intensity will be also not 0, but it is minimum. Here it is intensity maxima and here it is intensity will be minimum. Okay. Then what will be the waves with set of different wavelengths? So different wavelengths. Sometimes Thus the resultant waves will be the see, if you see here it is the sometimes resultant will be rough waves. Okay, so the difference, what is the difference between constructive interference, the waves are travels with same amplitude, and the resultant amplitude will be high and with the highest intensity, and it forms the bright fringes. In destructive interference, the amplitude will cancel out and that will be minimum intensity. Next, so what is the conditions for interference? What is conditions for interference? To produce interference, we require two coherent light sources. Then next one, the source must be monochromatic. The source should be monochromatic light, and source must be narrow and parallel. Source must be very narrow and parallel. Then two sources must emit light in the same direction. So what is same direction? The source must emit the same direction. The distance between two sources must be small, and the distance between two coherent sources and screen must be large. Then background should be dark to view interframe fringes. Generally, we can do the experiment in dark rooms. Why? Because if what light source, biggest light source is light, we can say that is sun. If you do the experiment in sunlight or light, we can't see that the fringes are dark and bright fringes. But that's why the wave of generally the optics, the light related experiments generally we can do in the experiments in dark rooms. So the background should be dark to view interference fringes. The amplitude of the light should be equal or nearly equal. Okay, the amplitudes of the light should be equal or nearly equal. So in constructive interferences, the two sources of light must emit continuous light waves of same wavelength and same frequency. So that is why we can use, that is sodium vapor lamp in Newton rings experiment, that is monochromatic light. So here it is the one more concept, that is interference in uniform thin films by reflection of light. So what, based on the interference phenomena, we have a concept that is uniform thin films by reflection of light. So what is reflection of light? Before going to reflection of light, we can know about the what is parallel thin film. What is parallel thin film? A transparent thin film of uniform thickness which is bounded by two plane parallel surface. Two plane parallel surface is known as parallel in thin film. Okay, which is parallel in thin film. Next, what is the principle? What is the principle? When the light is incident on parallel thin film, so we can impose the light or place a light in parallel plane thin film. Some portion of light will get reflected and from the top surface, and remaining portion will be transmitted into the film. So what we can observe here, if we place the light on transparent white light, some portion of light will be reflected and some portion will be remain transmitted into the lower surface, that will be on the below the transparent light glass. Okay, so this portion is transmitted light is reflected back into the film by the bottom surface. From the bottom surface, and emerges through the top surface. These reflected light waves are superimposed with each other and producing interference phenomena and forming interference patterns. Then that is known as principle of interference in thin film by the reflection. See, here it is. What we observed in principle, here it is the transparent glass surface. Here it is transparent glass surface. Here it is the source. A which is travels from light source and place on surface. Some portion of light will reflected, that is ray 1. Some portion of light will be transmitted on the second surface and some portion of light will transmitted and second ray, that is ray 2, and remaining here it will be the superimposition happened. The phenomena of superimposition will be happen here. So the light will transmitted to the lower surface. For other surface means nothing but a air. Here it is the place of air and here it is the place of air. And in between the glass plate, that is the thickness of the glass plate. Here it is the angle. What will be the angle here? A right angle triangle. What is that? A right angle triangle. So it is the, see, the uniform thickness of T is bounded by two parallel surfaces. So uniform thickness, it is bounded by two parallel surfaces. Here it is the refractive index of a material be a mu. Here it is a refractive index of a material, that is mu. The film is surrounded by common medium, that is air or both sides, that is here it is the both sides. Here it is the air place and here it will be the air place. So both are both sides. Let the monochromatic light AB, the monochromatic source, that is source AB, is incident on the top surface. See, here it is top surface, it is incident on the top surface, that is I. And the ray AB is reflected along BC. See, from B to C, it is reflected light and partially transmitted from B to F, that is BF, and it is makes a angle here, that is right angle triangle R with normal FG. So see, here it is FG, it is the right angle triangle. It meets in lower surface, right? At F, what is F here? Here it is the F, again partially reflected back. Here it is the partially reflected back, okay, and form along FD. Here it is partially reflected back, that is FD, while the major portion, what is the major portion here? That is F and K remaining. So remaining it will come out to air. Okay, the reflected ray, that is FD, refracts at the outer surface. Here it will be the outer surface and emergence out along DE, here it is D and here it will be the E. So from D to E, that will be the parallel ray B and C. Already we have another ray, that is ray 1, and ray 2 will be here in parallel ray, that is parallel ray. The waves traveling along the directions, that is BC, from B, C, then B, F and D, E. So these are obtained from the incident wave of AB. So here it is the incident wave. So we can hope you get the word is parallel thin film. So based on the diagram, the entire content is based on diagram only. So therefore the two light rays superimpose and produce interference patterns. Okay. Then condition for interference depends on the path difference between both 1 and 2 rays. Interference how it is depends, the path difference depends on the between two rays. So let us calculate the optical path difference between reflected rays, that is BC, that is BDF. So here it is the total path difference. Total path difference of two rays, that is geometrical path BFD minus and geometrical path BH in air. So what is that? The total path difference will be the in between surface of a parallel thin film and what refracted light, that is refracted minus refracted the light emits, that is the total path difference, that is total path difference between glass plate and outer glass plate, that is in air medium. So what will be the path difference? The total path difference should be, that is air and within the glass surface. So first one, the calculation of geometrical path, that is BFD in film. So what is the calculate the path, that is BF plus FD in the film. So we can take the angle, that is triangle BFG. So the opposite angle, the sine angle, that is right angle triangle, that is cos R, that is GF by BF. We can take the BF here. So that will be the BF will be the thickness. GF is the thickness. So that is T by cos R. Then similarly here it is triangle DFG. You can see the diagram. You can see that the diagram, that is a DFG triangle, that is cos R will be, you can take the FD here, that is T by cos R. So we can merge the both. Though we can calculate the both BF plus FD. Okay. So BF and FD, and here it is both BF and FD. So the difference. So what is the total? BF plus FD equal to T by cos R plus T by cos R. So we can common the factors, that is BFD, that is triangle BFD equal to, that is BF plus FD equal to 2T by cos R. Then coming to second one, that is calculation of geometrical path. Calculation of geometrical path, that is BH in air. So we can which is equal to the BG plus GD we can see the in diagram from triangle BGF, that will be angle tan R. We can take the BG, that is tan in T into the thickness, that T is the thickness here, that is T into tan R. So similarly, that is GD will be T into tan R. Okay. Then we can add the both. That is 2T tan R. 2T tan R. So then again triangle here it is BHD triangle. BHD, that is right angle sin I by BH by BD. Okay. We already know the BH value, that is BH equal to BD sin I, then 2T tan R sin R. So what is Snell's law here? That is sin I by sin R. So that is Snell's law. Snell's law, mu equal to sin I by sin R, that is sin I equal to mu sin R. Okay, so the equations, both equations, the total path difference will be 2 mu t cos R, 2 mu t cos R sin R by cos R. So from the equation, substituting the equation 4 and equation 9 in the equation 1. So what we get here, that is the total path difference 2 mu t cos R, 2 mu t cos R, 2 mu t cos R. So here it is the total equation, the total path difference will be 2 mu t cos R. So we can see the path change to here, that is from rare and medium to denser medium. So what is rare and medium in denser medium? For rare and medium in air and denser medium will be into the glass plate, that is denser medium. So the total path difference will be here, that is 2 mu t cos R, 2 mu t cos R minus lambda by 2. Okay, here it will be the cos law, and here it is the total path difference 2 mu t cos R minus lambda by 2, and here it will be the cases. What is that is maximum and minimum, that is dark and bright fringes of the constructive interference. The total path difference will be n lambda. We can substitute the values here, that is 2 mu t cos R equal to n lambda plus lambda by 2. So here we can take the common here, that is 2n plus 1 lambda by 2. So here we can take the common 2n. Here will be the lambda, that is 1 plus 1, and lambda by 2, that is 2 mu t cos R equal to 2n plus 1 into lambda by 2. So this is the condition for maxima. So why it is maxima? Because of constructive interference, that is 2 mu t cos R equal to 2n plus 1 lambda by 2. Next, condition for destructive interference, that is minima. Okay, here it is small n. Why it is n? That is where n will be the 0, 1, 2, 3 and so on. So this is for the film for bright under the condition, and bright fringes, that is bright fringes. Next, the condition for dark band and minimum destructive interference. That is the path difference will be 2n minus 1 into lambda by 2. So we can substitute the values here. So 2 mu t cos R, already we know the equation, minus lambda by 2. We can substitute the values here. The 2 mu t cos R equal to 2n minus 1, that is lambda by 2 plus lambda by 2. Right? So we can take the common, that is 2 mu t cos R equal to n lambda. Here it is 2 mu t cos R equal to 2n plus 1 lambda by 2, that is condition for bright fringes, and here it is 2 mu t cos R equal to n lambda. This is for dark fringes, that is condition for minima. So hope you understand. So why it is minima, why it is maxima, we are taking in path difference in parallel thin film based on interference. Okay, so this is the main important topic in parallel thin films in interference. So after this topic, we can go through the Newton rings. Thank you.